Hello, assalamu alaikum. I hope all are you doing good. In this video I am building a machine learning classification model in Python, and we will test how accurate it really is using a real data set, and we will also show confusion matrix graph. Here you can see we are going to build a k nearest neighbors classifier. It predicts the type of flowers based on measurement like petal length and width. Its flows will be input features. We will give input and ML model. After that will be flower type. First we import the libraries. Import panda is a PD. Panda help us work with data in tables. Import numpy. Numpy handle fast numerical calculations and arrays. Most ML libraries depend on it internally. Matplotlib let us draw chart and visualize graphs from our data. As we will do grab a chart for confusion matrix. Seaborn statistical visualization library built on top of matplotlib. Seaborn makes data visualization more attractive and easier, especially for ML chart. From sklearn, sklearn give us data sets and machine learning models. Here we will use neighbors in this video, and let's data sets. Model selection, import train test split. This will be used for splitting the data. From sklearn dot matrix, and matrix help us measure how good our model actually perform. Accuracy score measure the percentage of correct prediction. Classification score report show precision recall F1 score, and confusion matrix show correct with wrong prediction by class. Okay, let's run it now. And now load dataset. We load the IRS dataset and initialize it as an real dataset. It is a real dataset, and we have loaded the dataset. Now convert dataset to data frame. Data frame braces. So IRS data and columns is equal to IRS dot feature names. A target column div dot target equal to iris dot target now let's put the print the first 5 rows of dataset. Print dv.head is used for printing the first 5 rows of the dataset. So let's run this. Okay, this is the first 5 rows of dataset. You can see split features and targets x equal to d if dot dropped target, okay, and x is equal to 1 and y equal to df dot target. Machine learning needs two things: inputs and answer. X is input feature and y is the correct label, okay. So now we are going to move to the train and split train test split. We are going to split the data in train and split. So we split the data into training and testing sets. The model learn from training and data and is evaluated on test data, okay. So x train, x test, y underscore train, y underscore train, y underscore test, y underscore test equal to, now this is the function, equal to, this is the train, okay, train underscore test underscore split. This is used for this function used for splitting the data set. So xy train size will be equal to 0. 0.2 when you put the 0.2, it's mean the data will be split into the 20% and 80%, okay. If you put 3, it's mean the data will be split in 30 and 70. So 0.2 means 20% and 80%. Random state put 42. Now print the percentage, the data, divided data, okay. So for breaking the line, train size, so train size, length, in function used for length. So x train and print test size and length in function and x test. Let's print the, so here is the train and test size. 30 is the 20% of our data set and 120 is the 80% of our data set. The total is 150, okay. So it's split it, and this is the size of train test data set. We had already split that, and this is the size. So now let's move on to the, now create KNN model. KNN means k nearest neighbors. When a new sample comes, it checks the closest known sample and odds. So model neighbors dot k neighbors classifier, we will take this function, and n underscore neighbors equal to 3 will be the k value, okay. It's mean like asking your three closest friend what the answer is. Majority wins. If the majority answer yes, it will be the yes will be the win part. If the majority say no, the no will be the win part. So now train the model dot fit x underscore train y train. Now we hit train the model here. uh, Here when we train the model learn pattern from the training data, which here we provided the x underscore train. So now prediction. Now we ask the model to predict flower types for the test data, which we had splitted x underscore test, saving the splitted and saving the x underscore test. So I had run that, and now move to the accuracy. Now do evaluation. So accuracy uh, accuracy equal to use their function accuracy underscore score, and that will be the y underscore test and y underscore predicted data, which means the predicted data. And here is our accuracy score. This tells us how often the model was correct. Okay, now let's print the accuracy. Here the app mean we have put it before the string. It's mean the raw string. So accuracy, we are going to print the accuracy. So let's put a symbol which make little bit beauty of the result. So I put it the check symbol. Now print the classification report. Classification report precision means how the correct prediction are. Recall means how many are cases we catch. So here we print the report, y test and y print, and let's here put a symbol. I am using this one. Confusion matrix y underscore test and y underscore predicted predict. Wow, accuracy result is very amazing. And here is our accuracy score. This tells us how often the model was correct. And classification report precision means how correct prediction are. Recall means how many real cases we catch. And confusion matrix heatmap. This is also amazing. Let's visualize the confusion matrix. Confusion matrix heat map. This is our confusion matrix heat map. This chart show correct prediction and the diagonal, any up diagonal numbers are mistakes. So here our confusion matrix heatmap. Now experiment with the k values, k difference value. Let's try different k values and see how accuracy change. So let's change the k value, and 3 is the here 3 is the k value. Now I'm going to change it to 5. Always we are putting the k values in odd. Now prediction. Now for, let's see, the accuracy did not change. Okay, now let's try with the different. Now I'm putting the 9. Now let's see, here it is also, and let me run this too. Now the accuracy is downgraded, so it's now test with the 11.